Vijay Garu.
Good evening to all the participants and welcome to the sixth day of the NDRF's online internship program. Today we have two very exciting topics of 45 minutes each. So it will be a total 1.5 hour program today. So the first topic is on modern quality practices in aeronautics by Shri T.V. Kishore. And the second 45 minutes will be taken up by Dr. Archana Magadi, who will be speaking to us on design thinking. So and as usual, any questions and that you have, you please type it up in the question and answer box. And at the end of the each speaker's topic, we'll try to have them answer it. So we will start today on the first topic, which is the modern quality practices in aeronautics by Shri T.V. Kishore, uh, who is the Chief Manager of Quality at Hindustan Aeronautics Limited Overall Division. He has completed his BE in Electrical and Electronics and MS in Quality Management. He has 19 years experience in quality assurance in the overhaul division. He has worked on Mirage 2000 aircraft maintenance and upgrade, and in overall of Jaguar, Kiran, and the Hawk aircraft. I request Shri T.V. Kishore to start his talk.
Good evening to all. Thanks, Mr. Vijay, for the introduction. As you introduced, as Mr. Vijay told, this is Kishore TV, Chief Manager Quality. I am from Hindustan Aeronautics Limited Overall Division, where I have in quality control for the last 19 years. And my area of work has been overall and the upgrade of defense fighter aircraft, especially Mirage, Jaguar, Kiran, and Hawk. So today's topic is modern quality practices in aeronautics. The agenda for today will be covering these aspects. Just give a brief definition of what quality is and what quality means. Then what is quality control and what's quality assurance? What do these terms mean? And the concept of processes, and just to give you a peek into some of the quality practices or concepts used in the aeronautical industry, I'll be touching upon a few topics like first article inspection, non-destructive testing, FOD control, and traceability. Then we'll have any queries that the participants have. First, let us start with what is the meaning of quality. The standard definition of quality is this, what you see on screen. The degree to which a set of inherent characteristics of an object fulfills requirements. So basically the keywords are the ability, the characteristics and requirements. So the ability of any product or service to meet requirements is what is the meaning of quality. So what are these requirements? These requirements could be something which is stated by the customer explicitly or something which is implied. For example, if you go to a restaurant, the quality of a restaurant depends based on the consumer. If you are looking for a quick lunch or a quick bite, and then starting your day, then a Darshini type of restaurant will meet your quality. But if you are looking to have a birthday party or a wedding anniversary celebrated, you would like to spend a lot of time sitting with your family or with your spouse and to have a very relaxed dinner, then a Darshini type of restaurant will not meet your requirement. So, uh, what type of quality or what type of requirement the customer has? If the product or service is able to give that particular meet that requirement, then quality is being fulfilled. That is the fundamental understanding of quality. Now let us see these words quality control and quality assurance. These terms are used quite interchangeably in the industry. but we'll see what exactly these two terms mean. Quality assurance. Quality assurance is something which is process oriented, which is nothing but a set of activities which ensures that the processes are controlled so that the products which come out of those processes are of the highest quality. This is what is quality assurance. And what is quality control is nothing but more product oriented. It is nothing but a set of activities which focuses on identifying defects in the products which are being produced, so and take some actions so that those defects do not reoccur. One of the most important activities in quality control is obviously inspection, where you do check the result of what you have manufactured. And the focus on in quality assurance is always on defect prevention, whereas the focus in quality control is defect detection and correction. So quality assurance, as you know, as you understand, it's a proactive process, whereas quality control is a more of a reactive process. So how do you achieve quality assurance? Quality assurance is achieved by designing a proper system, what is called as a quality management system, and ensure that processes are put in place so that everyone who is part of the organization understands what is his role, what are the inputs, what he is supposed to get, and what are the outputs which he is supposed to produce. So an establishment of a good system with periodic audits to check whether the system is working the way it is desired will form quality assurance. Whereas quality control is obviously finding out what are the problems, using certain specific tools and equipment, and eliminate those problems so that the product what gets or service whatever gets delivered is of the highest quality. So examples of quality control and quality assurance activities, this quality assurance activity audits what are carried out to check whether the systems are in place is one of the primary quality assurance activity. Establishing standards, creating clear-cut documentations so that there is no ambiguity in what needs to be done, who needs to do it, and how it is to be done. This type of documentation is also a quality assurance activity. Developing checklists, establishing quality management systems like AS 9100 or ISO 9000 and getting yourself certified to that standard is one quality assurance activity. Whereas quality control is performing inspections, performing testing, conducting quality control reviews. So these, if you see, are all inspection activities which decides how the product what you have manufactured has come out. Does it really meet the requirements, and what are the defects which are observed, and how these defects needs to be corrected so that they don't happen again. These are quality control activities. So an industry, these quality control and quality assurance activities happen on a continuous basis in any industry, so that the output what the industry gives is of the highest standard. Let us come to quality triangle. Whenever the word quality is told, going by the definition of the word quality, it means the ability of a product or service to meet the requirements. And what are the requirements from the customer? One is product conformity, which means the product what is made is able to meet the perform the way it is designed to perform, or the way it is desired to perform. And another aspect of requirement is the product should be available when this customer wants it. So if the product is supposed to be delivered in a certain time frame, it should be made available. That is called as on-time delivery. And next is cost. Obviously, the customer will expect the best performance on time at the lowest cost possible. So these, when the word quality is used, it implies these three concepts. One is the ability of a product or service to function the way it's supposed to function, and the ability of the organization to deliver the product in the time which has been committed, and to do both these things at a very optimal, justifiable, and acceptable cost. These are the three aspects which is called as the quality triangle. So any organization will be focusing on these three parts of the triangle and following certain principles as far as quality management is concerned. These are the seven principles, 8 principles. One is customer focus, commitment from the leadership, people engagement, process approach, continuous improvement, evidence-based decision making, and relationship management. Customer focus means obviously for any organization to survive, the customer has to return, come back to the organization to buy its product or services. So the very purpose of existence or the very reason that the business sustains is because of the customer. So customer should be the primary focus of any business. Next is commitment from the leadership. Whatever the top management or whatever the leader of the organization talks, that is where the organization goes forward. So this, unless there is a very strong leadership, people in the organization will not be able to be, will not get aligned to what is the requirement of the customer, and this push should come from the top management. That is the second principle. Next is people engagement. Whatever any organization is, even though it has got buildings, infrastructure, tools, machines, but the fundamental fuel which runs the organization is its people. The people are responsible for creating systems, following systems, making products, delivering it, correction, everything comes from the people. So the ability of an organization to deliver the right product comes from its people. So engagement of people and giving them proper leadership and guiding them towards the goal is very important. Next is the process approach. Over the process approach, we'll see in the next slides. Continuous improvement. Any organization can improve, can sustain only if, when it learns from its past mistakes. This learning helps to iron out deficiencies, what is existing, and then the organization can refine more and more so that the customer's requirements and the product and service is delivered in the way the customer wants. Next is evidence-based decision making. This is an aspect which is very important in any organization. Any decision which is made in an organization should be based on facts rather than whims and fancies of some individual. Because the statistics, there are a lot of statistics tools nowadays which helps the organization to know where its processes are leading, where they are making mistakes, where improvements are required, and any actions or decisions which are made should be based on this data. So next comes the relationship management. When we say relationship management, there are two types of relationships in any organization. One is the relationship which the organization has with its customer, and the relationship what it has with its suppliers. Customer, obviously, as we have seen earlier. In case of suppliers, any organization converts some raw materials or into products and delivers it to the customer, and these raw materials or inputs come from various suppliers which does. So as long as the supplier is kept happy, the organization cannot keep its customer happy. So relationship management is an important principle of quality management. So all these aspects, what is shown in this slide, forms the principles of the quality management in any organization. Process approach. So this is one of the principles, and what is a process? A process is nothing but a set of activities which converts an input into an output, using certain controls, using certain resources, and in the presence of certain controls. The process approach is very important in any organization because basically an organization converts inputs like raw materials in case of an aircraft industry, in case of a where I am coming from, it's a maintenance repair organization, overall organization where we overall aircraft. So in this industry, if you see, the input is a used aircraft, an aircraft which is due for some servicing. It comes into the organization. Some processes are carried out on it, and when the aircraft comes out, it's as good as a brand new aircraft, which can fly for another certain fixed number of hours. So this process of converting a used an unserviceable aircraft into a serviceable aircraft is the big process, is the macro process in an MRO organization like overall. If you break down this major process, there are a lot of smaller activities which happen in this organization, which I will come in the next slide. And this is that. So an aircraft, when it is converted from an unserviceable aircraft to a serviceable aircraft, it goes through these steps, what you see on screen. First is the aircraft is received from the customer, then it goes through what is called as confidence checks to ascertain what is the level of work which needs to be done on the aircraft. Then the aircraft is stripped bare of its components, which is the removal space. And once it's removed, the aircraft undergoes a cleaning process. And once the aircraft is cleaned, then comes the pre-survey. Pre-survey is nothing but an inspection or a visual examination of the aircraft to find out what are the defects noticed on the aircraft, what are the areas where we need to do the work, where reconditioning has to be done so that the aircraft can be made as good as new. So this pre-survey is in an MR organization. This pre-survey is one of the most value-adding organizations where value-adding activities where we find out what work needs to be done, and this pre-survey output of the pre-survey activity defines what work needs to be done on the aircraft. So based on the pre-survey, you see the repair activity happens, and once the repair activity is completed, the various items which have been removed gets equipped back, and the aircraft gets checked functionally for various systems, step by step. And then the engine is installed, and we do an engine ground run, and then it goes through flight trials, contractor flight trials, customer flight trials. And then once in the flight trial, the aircraft is actually put to its final functional use. The aircraft flies, its performance is measured, and once it's satisfactory, then it is ready for delivery to the customer. So this is a process which is, this is the flow of events which happens in an aircraft maintenance industry. Similarly, any industry, this is there will be a set of processes which are unique to it. But basically, if you see, every process will be nothing but an input getting converted to an output. So this is the core process what is there in an aircraft industry. When we say process approach, what we show in this previous slide is nothing but now we see these 10 stages or 12 stages what is shown here. The major overall of an aircraft has been converted into these 10 or 12 stages. Further, if you go into detail, each one of these steps can be further broken down into simpler elements. So the lowest or the most elemental form of activity can be considered as a process. So this process approach, what it helps, how it helps is, it helps us to identify what are the inputs required for a particular activity and what is the expected output. And when you have an output which is expected, and when you measure the actual output what has come, and when you see when you compare whether the expected output is, when the measured output is meeting the expected output, then you have a good process in place. So by breaking down the major process into several elemental processes and measuring the output of each processes, we will come to know whether we are doing a good activity as a whole. When the delivered output is not meeting the requirements, then we go back to one of these areas. Either there is a problem with the inputs, or there is a problem with the controls, or there is a problem with the resources. When we say resources, it means the people or the methods what we are used to produce the product, or the tools that are being used. So these are the This is the benefit of using a process approach. So this representation here indicates how processes work in any industry. You can think that the entire industry, any organization will have several processes which are going parallel. Some of these processes give an output. The inputs of one process will be the output of an earlier process, and there will be sequential movement of processes or parallel movement. So, and so you can see that it is a big chain consisting of several links, several gears like this. If any one of those gears do not do its job properly, obviously the output will not be of the desired. So by adopting a process approach in any industry, you will be able to control the quality of the product, what you will be able to measure the output of each processes. When you are able to measure, you will be able to control it better. And once you are able to control, then you can meet what the customer wants. So that's about the process approach. Now, coming to the topic of the day, like some of the modern quality concepts used in the aeronautical industry. I just got to showing here 4 different concepts. These are all not unique to the aircraft industry. These are available in other industries also, but they some of these, for example, FOD control is very unique to aircraft industry. The topics for what I'm going to cover are first article inspection, non-destructive testing, FOD control, and traceability. What is first article inspection? First article inspection is a concept which is used in the aircraft industry in order to ensure that the production process, what is being followed, is able to produce products that meet the requirements. For example, in the aircraft industry, whenever an article is manufactured for the first time, you have to note that in an aircraft industry, safety is of paramount, because unlike other products in the aircraft, an aircraft is a machine which takes off from the ground and flies, and it has to safely return. It's not like a car or an automobile which can be parked at the side of the road and then service. So there is no second chance in an aircraft if one of the parts fail. So it's very important that any of the part in the aircraft should work every time the same way, and there is no question of any failure. So with that in mind, the first article inspection concept is made. What is first article inspection? As I told, it is an activity where before you make a new part or make a part for the first time, it needs to go through a certain process, and a meticulous inspection needs to be done right from the raw material stage till the final product part is made, to ensure that the process which is used, the persons who are doing it, the documents and the methods that are followed will result in the product which exactly meets what the requirements are. So basically, this in the first article inspection, the first production run is done using all the required production process, documentation, and tooling. And whenever there is any change in one of these processes or one of the documentation or tooling, then this process gets repeated, so that the entire process is again done, so that there is no because of the changes of any in the process or documentation or tooling, there has been no change in the quality of the final product. So by doing first article inspection, what are we able to achieve? When you do first article inspection, you will be able to find out if there has been some wrong material which is used, a component or material which is being made is poorly positioned or poorly set up, and if there is a inconsistent quality in the material or component that is used, and the wrong processing equipment is used, and poorly set processing equipment done, or the first article inspection also helps to confirm whether the verification processes used in checking whether the item which is produced is good or not is also correct. So it helps, it will point out any inability on the process to confirm whether a part which is produced is acceptable or not. So these are the aim or objectives of doing a first article inspection. So how is first article inspection done? Is it's production run is done. The first production run is made, and few parts are taken at random, and these parts are checked for measured, tested, and inspected as what the documentation says. And then once this is done, a proper documentation is made so that at the at the end of it, or at the in future, whenever we encounter any problems, we can always go back and find out what was the mistake we done in the first article, and necessary corrective action can be taken. And there is a standard in the aerospace industry which is used for this particular first article inspection, and that is called as AS 9102. So this standard clearly tells how first article needs to be done, what are the steps to be followed, and at the end of the first article inspection done, what are the records to be maintained, how these documents needs to be stored. Next, I come to another topic called the non-destructive testing. So this first article inspection, what we saw was it basically contained, it is basically an inspection activity. Can be categorized as a quality assurance activity comprising a lot of quality control activities. Whereas non-destructive testing, which I brought out here, is purely an inspection activity, and it is very critical in the aircraft industry because it helps us to detect some failures without destroying the component. So, as the name says, non-destructive technique, it's the process of inspecting, testing, or evaluating any materials or any defects or discontinuities without destroying the serviceability of the part of the system. In other words, when the inspection or test is completed and the part is still can be used, then it called as a non-destructive test. So there are several tests where the part is destructed to check for its condition. But in the case of the aircraft, an aircraft is subjected to a lot of stresses. Some of the structural components in the aircraft are subjected to very heavy stresses. So there is a chance of failure which can creep in. So non-destructive technique testing is a technique where you carry out these tests at periodically defined intervals. Like an aircraft's life is measured in terms of hours or in terms of calendar period, like months or years. So after an aircraft has undergone a certain number of flying hours, like maybe 50 hours or 100 hours, as decided by the designer, testing of the aircrafts is carried out so that as a preventive measure, in case you can detect any defect which has crept in during its usage, and necessary repairs can be carried out so that the aircraft can be again put into use. So let us look into what are the techniques normally used in the aircraft industry for the non-destructive testing. So one of the primary, very simpler technique is a visual inspection. Other is the magnetic particle testing. Other is liquid penetrant testing. Next is the eddy current testing, ultrasonic and radiography. These are the techniques which are normally used in the aircraft industry. First is visual inspection. Visual inspection is nothing but using a naked eye, checking the aircraft, checking any component for any failures. So in an aircraft, if you see there is comprises of so many things: the rivets, pipelines, the skin, any damage which is accessible to the naked eye can be seen using a torch. In case where there is there are some inaccessible areas, use a special equipment called the boroscope, what you see on screen. This is one of the fundamental ways of checking whether the aircraft is serviceable or not, or if there are any defects. So after every aircraft goes for any flight, or it comes back after any flight, this visual inspection is mandatorily carried out to ensure aircraft structure is still holding good. Next is the magnetic particle inspection. Magnetic particle inspection is another indicative technique which is used on ferromagnetic materials, materials which can be magnetized. So what you see on screen is nothing but a sheet metal item which has been installed on a magnaflux equipment. The magnaflux equipment is the equipment which is used for carrying out magnetic particle inspection. Basically, what happens in this is the part which is to be checked, which is a ferrous material, is magnetized, and then fluid containing some magnetic particles are poured onto it. And as the part is magnetized, and if there is a defect, a crack, what happens is the magnetic particles in the fluid gets aligned to the defect, and if the defect is in the form of a line, all the magnetic particles get aligned in the form of a line, indicating the presence of a defect. In the screen, what you see is the lines. What you see in the center of the screen is basically defects which have been formed by the magnetic particles in the fluid. This is a special type of magnaflux, which is called as the fluorescent magnetic particle inspection, where the fluid used is a fluorescent material, and the defects can be seen using a special ultraviolet light. Next, what we see is here is the dye penetrant example. Dye penetrant testing is a technique which is used to detect surface and subsurface cracks. This is based on the principle of capillary action, and any metal surface which is suspected of having cracks or which needs to be tested, as a first step, a colored penetrant, usually in the form of a red colored dye, is applied. Once, which you see in the first block, once this colored penetrant is applied, and then the surface is thoroughly cleaned, and you see wherever cracks are there, the penetrant has penetrated and is lying in the subsurface. Once it is cleaned, and then the developer is applied. The developer is nothing but some like a white chalk material. When that is applied, whatever red dye has gone into the subsurface cracks, due to capillary action, come out on top and get exposed in the form of a red color, which helps to identify any surface or subsurface cracks. This is called as the dye penetrant inspection. Next, what we have is the ultrasonic inspection. This is another technique to identify cracks inside, not the surface level, so at a certain depth inside the material. So this is again based on the ultrasonic principle, where a probe is used to generate ultrasonic waves, and on the left-hand side where you see there is no defect, the display shows that the reflection of the ultrasonic wave from the end of the defect-free section is in one particular fashion, and wherever there are defects, which you see on the right-hand side, there is a defect in the center of the piece, you see the ultrasonic wave gets reflected from between, and accordingly, if you see the display shows a different sort of a waveform, which is an indicative of a defect which is present in this piece. So this is the ultrasonic technique is used predominantly in the case of composite materials which are used in the aircraft. The next, another technique what is used is radiography. This is, in other words, is the X-ray machine. It is similar to the X-rays what is used in the medical industry. An X-ray film is placed on the other side of the piece which needs to be checked, and a strong beam of X-ray beam is directed onto it, and once the film gets developed, wherever the defects or any cracks are there, this gets depicted in the developed film in the form of different color patches, because of differential absorption of the X-rays. So this is also another popular, widely used technique for measuring, for checking cracks. And the final technique, or the fifth or the sixth technique, is the eddy current check, which is nothing but based on the eddy current principle. Any magnetic field on a metallic surface will develop eddy currents in the test piece. So these eddy currents are sensed, and using this, if there is a defect in the piece getting tested, these eddy currents are disturbed, and the resulting magnetic field from the eddy current gets disturbed. So this disturbance is measured. The presence of a disturbance indicates that the presence of a crack, and the absence of any such disturbance indicates that the crack free area. So again, eddy currents are used to check surface cracks, surface and subsurface cracks. So these are the techniques called as non-destructive testing techniques, which are used in the aircraft industry for checking the integrity of the aircraft structure and its parts. Now, another unique thing which is practice, the quality practice in the aircraft industry, is the foreign object damage. So, as I told, the aircraft is a machine which flies, takes off, and it needs to land safely. One of the most important things to be ensured before it takes off is there is no item installed or present in the aircraft which does not belong there. If you see, there have been so many instances where aircraft have been lost because of very small objects in the aircraft which were originally not supposed to have been there. So, what is a foreign object? So, such objects which are there in the aircraft which are not supposed to be there is called as a foreign object. So, what is a foreign object? And this is called as FOD. FOD, the word FOD means two things. One is it's called as foreign object damage or foreign object debris. So, any damage which is attributed on an aircraft because of a foreign object is called as a foreign object damage, or any item which is left in the aircraft acting as a debris and which is not supposed to be there in the aircraft, that is called as a foreign object debris. So, the word FOD is used interchangeably as foreign object damage or foreign object debris. So basically, what is it? Anything that is where it does not belong can be considered as an FOD. So here you see the picture of an engine blade, compressor blade, which is damaged because of an FOD. You can see that this is the picture of the Concorde aircraft, and this aircraft picture, what you see is an accident which has happened on the last flight of the Concorde. The Concorde aircraft is no more flying. And the reason for the crash for this aircraft was because of an FOD. In this case, it was not an FOD which was inside the aircraft, it was an FOD lying on the runway just before takeoff. And what you see on the right side of your screen is a piece of engine cowling which was left behind by an earlier aircraft which had taken off. And that piece of engine cowling was lying on the runway, and the tires of the Concorde ran over this metallic piece. The tire got burst, and a lot of debris came out, and one of these debris hit the Concorde's fuel tanks, and there was heavy fuel leak. And as you see on the left side of the picture, this fuel leak had caused a fire which caused the aircraft to crash. So it was a very, very small item which caused this crash, and as it happened, this happened to be the last flight of the Concorde. Okay, the accident was not the only reason for the grounding of the Concorde. It was also, there were also economic reasons behind that. But still, this indicates how important it is in the aircraft industry to ensure that no foreign objects are available, or by mistake do not enter into the aircraft or in the surroundings of the aircraft. So in any aircraft industry, this is one area where a lot of focus is there. So what are the steps which is practices which are done to avoid this foreign object damages? If you can see, basically it's about housekeeping and cleanliness. So clean as you go. Anytime any activity happens on the aircraft, it is the responsibility of everybody involved to ensure that it is remains clean and there is no undesired or unnecessary items lying around. And next is identify certain areas in the working place as which are critical areas and ensure that no FOD items are left behind. Then another practice which is followed not only in the aircraft industry, you would have seen in many places, in the automobile industry, the automobile service stations, where tools and hardware which is used during the activities are accounted at the end of every shift. This is achieved by using something called as shadow boxes, where all the tools are lined up in the shadow box, and at the end of the day, if some tool is not there in the shadow box, it means that the tool is missing, and it could once a tool is missing, then it should be the worst. We should always be thinking in the worst possible way that the tool is available somewhere in the aircraft, and then they are looking for it. And accounting for tools ensures that FOD is eliminated. Next is using various tools and techniques like X-rays, boroscopes to ensure that all inaccessible areas are thoroughly checked. And another important thing is the people working wear a proper attire. Attire means you have seen people, aircraft industry people working with, not only aircraft industry, again going back to the automobile industry also, people working with coveralls. These coveralls is a specific attire for the aircraft industry to ensure that whatever tools or whatever small items are used, there are several pockets in this attire which helps people to store pens, small mirrors, everything, so that nothing spills out and falls onto the aircraft or into the cockpit where it is not supposed to fall. Next, the last of the practice which is followed in the aircraft industry is one is traceability. The concept of traceability is very important. What is traceability? Traceability is nothing but the ability to trace every item what is used or installed on an aircraft. Why is it so important? Because if you see, the traceability is the ability to track and trace each component that is fitted onto the aircraft from the suppliers and manufacturers through the various assembly processes up to the stage of delivery to the customers. So, by ensuring that traceability is maintained, we will be able to identify at any point of time what is the material used on an aircraft, who has supplied that material, what process was used in the manufacture that particular part, who has carried out that particular process, and what are the measuring instruments that were used, and what are the tools that were used. So all these things can be identified by having proper traceability. So why is traceability important? One is it will help us, any organization, to ensure that what is the origin of a particular product or a raw material, and it will help organization to give assurance to everybody that the items what are used in an aircraft or any other product is from the genuine source. It is traceability is very important in another aspect, like tomorrow during the process of assembly or during the after delivery of an aircraft from an item, a snag or a defect is reported by the customer, or during in-process inspection if a defect is reported, it helps us to identify from where the item, the first step is to identify what caused the defect, and once the cause of the defect has been identified, what is the source of that item, or who is the person who has worked on the item, or which tool was used for preparing, manufacturing that item, or which measuring instrument was used to measure the item. So the fault could be in any one of these items. The root cause of a failure could be any one of these. It could be the man who has worked on it, the method what was followed, the machine what was used, or the measuring instrument what was used. So by having proper traceability documents, it will help the system to go back and identify what exactly was the reason and correct that. So this is one of the important requirements why traceability is required. Next is it also helps us to have better customer relationships. So we all we will have heard of this concept called as product recall. What is product recall? Product recall is something which organization resorts to when it finds out that certain after delivery of the item to the customer, there are certain defects which are noticed, which have been noticed at a later stage, and by that time it is seen that many of the products have been already shipped to the customer. So, as a responsible organization, what an organization does is informs the customer that there has been a certain defect observed in a certain batch of items, and these items needs to be sent back to the manufacturer in order to rectify it and repair or replace it with a new one. So this type of product recalls have happened several times. One of the most popular or famous incident was when Nokia had problems noticed in its batteries of the phones in which it had supplied, and there was a mass recall of many of the batteries, and many of the customers were given a free replacement of the batteries. So this product recall can happen only when you have a very good traceability in place in the system. So it will help you identify which are the products which have been affected, which particular batch of items have been affected, and helps you to call back the defective items which have been already delivered. So this is just an illustration of what happens in an industry. See, if you see so many raw materials are used in the manufacture of a item. If you see on the right side, the assembly one, which says it comprises of nearly 4 different sub-assemblies, and these 4 different sub-assemblies uses their own raw materials, A, B, C, D, different, and each of these raw materials come from the different suppliers. So the final product what goes to the customer comprises of so many elements which comes from different suppliers, different sub-assemblies. Unless we have a very proper way of documenting which item has come from which supplier or which process it has gone through, it will be difficult for us to identify any problems or defects which comes in a later stage. So this is a small example which I have shown talking about batch numbers. How is traceability ensured is normally if you see in any of the products what you buy, if there is something called as a batch number mentioned. This batch number is nothing but a reference to a particular batch of items which are produced in a certain day or a certain hour or a certain time. So assume an item in the market has some sort of a defect. So the first step the organization or the manufacturer does is refer to the batch number, go back to that batch number and identify which all items were manufactured with a particular batch number and take steps to correct the problems noticed in the batch. So this is how traceability is identified so that products become easily traceable. Now, with that I come to the 4 different concepts what I got. Concepts, or you can say quality practices, which are followed in the aircraft industry. These are just small samples, examples which are given. These 4 things what I've told are there in any aircraft industry, and not only aircraft industry, some of these concepts are there in other industries also. Likewise, there are so many very specific, unique practices which has followed in the aviation industry, and these things are all told in many of the standards which is used in the aviation industry, particularly the quality management system standards, which is AS 9100, 9101, 9110. These are the standards used in the aircraft industry which specify what are the quality practices or concepts which needs to be incorporated in an aircraft manufacturing or maintenance agency, so that the processes what are followed will result in an aircraft or a product which is of the highest quality. With that, I come to the end of this presentation. If there are any queries, you can please ask.
There are some questions in the Q&A box.
Yeah. Okay. So I'll just read out the questions so people know. What one of the questions is, what is the latest technology on non-destructive testing on ground? Some of the what techniques I told 5 techniques in the presentation. They are well, they are the most widely used, and one of the latest technology which not mentioned in that is again more refined version of ultrasonic inspection, which is called as phased array ultrasonic inspection. This phased array ultrasonic inspection is a new technique, not a new technique, one of the newer techniques which helps in identifying subsurface cracks or defects in the aluminum spars of the aircraft. So in this case, instead of a moving probe, there is a phased array probe which generates the ultrasonic waves in different phase angles, which helps to cover a wider area, and more accurate results are obtained by using this phase array technique. Next, there is a question: what is the biggest challenge faced by approving an aircraft to fly on quality pass? See, the aircraft industry, as I told, safety is one of the most important things in an aircraft industry, and there is nothing which is important, not important in an aircraft industry. Any item which is installed on the aircraft takes off along with the aircraft and can bring down the aircraft if it is not the correct item. So there is every item which goes into an aircraft has to be of the exact specification, or whatever is designed, it should be of the it should meet the safety requirements what is already documented. So there is nothing which can be considered important or not important. The next question: why jet aircraft production taking so long period? This question, see, actually, I cannot tell about the exact numbers of aircraft which are produced by Boeing. These are top-notch industries which have been producing aircraft at a very fast rate. It is not that it is slow, but maybe in the aeronautical industry we do not have any major civil manufacturing. We do not have any civil manufacturing industry, and most of even our defense aircraft, whatever we have with us, except for a few, we are dependent on the foreign OEMs only. And as you said, yes, it takes a lot of time for producing a jet aircraft, because right from design stage to qualification and certification and putting it to use, an aircraft production always is a very long cycle activity, because the amount of testing and qualification involved is huge. The cost as well as the time is a very huge activity. The question is, how can we improve the quality of aircraft that at least it can withstand a bird hit? See, one of my topics, what I told was the FOD. Bird hit. See, when I want to tell you one thing is, whenever they classify aircraft accidents, they find out what is the root cause of an aircraft accident, and major accidents, factors which cause an accident are categorized as like human error, pilot error, material failure, or some sort of design issue. Corrective actions, as far as these things are concerned, are deliberated widely and the actions are taken. But when it comes to bird hit, they come under a separate category. So as of now, there has been no technology which has been found to be effectively foolproof against a bird hit. So problems of bird hits are still there. The only way to ensure that bird hit related accidents are reduced is to ensure that the surroundings where the aircrafts take off and land are kept bird free as much as possible. So there are certain questions on related to internship in a child. These things you should log into the website and then you can find out. You may have the answers there. Okay, regarding NDT, I have already answered. Uh, so one question is about automation. Is automation employed in testing procedures? Yes, there is a lot of automation which has been uh, done, but as far as the maintenance industry is concerned, see, aircraft are still being flown by pilots. So we have not yet reached a stage where pilotless, the research on pilotless aircraft and similar concepts are still underway. But as long as the pilot is there in the aircraft, whenever, as far as the maintenance industry is concerned, testing has to be manual. Uh, what the pilot undergoes when he takes off in an aircraft, the same things have to be tested on the ground by sitting in the cockpit and employing testing procedures. So, in the maintenance industry of the aircraft, automation is not there as to a large extent. I think I've answered all the questions. Okay. What are the primary measures? Somebody says there are a lot of accidents happens due to landing gear. How frequently a landing gear will be tested for checking the proper working? So this is okay. This is the landing gears. See, every item which is installed on an aircraft has a certain life. As I told, it will be either in terms of flying hours or it will be in terms of landings. Since landing gear is subjected to more and wear and tear whenever the aircraft lands, so the life of a landing gear is already is defined using a number of landings. For example, landing gear's life will be 2000 landings. Whenever the aircraft has completed 2000 landings, I'm just telling you an example. It has to go to its maintenance agency. It has to be stripped open completely, and then overall land, and then it can certify to fly for another 2000 landings. So, in addition to that, whenever a landing gear is removed and reinstalled, certain checks are prescribed, and these checks are done on any aircraft. You mentioned there are a lot of accidents happens due to landing gear. No, I don't think that's a right statement. Landing gears are not the major cause of any accident. Somebody else said, what is your take on the Kozhikode plane crash yesterday? How do you think it could have been happened? I think details have not yet come. Uh, it's whatever happened is coming is in the news is not 100% may not be true. So we'll have to wait for some time to know what would have happened.
Okay, thank you very much,
Yeah.
sir.
Yeah.
I think you have. Okay, so I thank Shri TV Kishore for his very interesting topic on modern quality practices in aeronautics. And any other questions? I see a couple of more questions coming in. I request you to kindly email us the question and we'll forward it to Shri Kishore and request him to answer that. So we are already running a little late, so we will go on to the next topic for today, which is design thinking by Dr. Archana Magdi. She's an assistant professor at RV College of Engineering, Bangalore, and she's a certified Lean Six Sigma black belt, having 17 years of experience uh, in Six Sigma process advocacy, lean management, business operation, quality management, etc. So I request Madam to give her talk on design thinking.
Thank you, Vijay sir. Good evening, everyone. I'm privileged to have gotten an opportunity to talk about Six Sigma, and I also will bring in some concepts of design thinking because the world is moving towards innovation, and I think if I don't cover some aspects of design thinking, then I would probably be missing out some information. So bear with me. I think I have half hour. Do I have a little more time? Vijay sir, do I have another 30 minutes?
I think you can take a little more time. It is not a very hard, rule that you have to finish it in that time. You can what you call finish it in a reasonable time.
Great, thank you so much. I would actually appreciate Mr. Kishore for covering very good concepts on how HAL has applied quality. And the good part is I and him didn't interact, so some of my slides don't overlap or there's. Let me go ahead and share my slide here. Usually when I handle these sessions on Six Sigma design thinking, it's more of an interactive face-to-face where I make our students do some activity. In that process, I try to come up with an activity where maybe I could try this online, but I can't see the students' face. But what I want you guys to do is pick up a waste paper and keep it handy, any paper, any size, just keep it handy. What I would like to do is I can only see some of our core members on the video, not everybody. So maybe I'll request the core member on the video just to do the same so that we can just show students. I just want to convey some message through this activity. Having said that, let me get started. So today I will be talking majorly about Six Sigma. It's a roadmap to process improvement. After I introduce what Six Sigma is, I will be talking about the history of Six Sigma. There are two main models that are used in Six Sigma, which is DMAIC and DMAD-V. DMAIC stands for Define, Measure, Analyze, Improve, Control. And DMAD-V stands for Define, Measure, Analyze, Design, and Validate or Verify. With that, I will also move on and talk about lean methodologies and how Six Sigma and lean have been a good model for many companies combined together. And I also want to talk about, is really Six Sigma fading away? Are there companies still using Six Sigma? And where is the world actually moving towards? And then I will conclude by talking about design thinking. What is Six Sigma? Six Sigma, it's a method that provides organizations with tools and it helps to improve the capability of their business processes. This is the definition given by American Society for Quality. This increase in performance and decrease in process variation leads to defect reduction and improvement in profits, employee morale, and quality of products or services. Six Sigma quality is a term generally used to indicate a process is well controlled. The various definitions that are given to Six Sigma, many companies, according to their convenience, they have defined Six Sigma in terms of statistics. And one such company is GE, which actually gave a statistical definition to Six Sigma, and it called it as a 3.4 defects per million opportunity, or 99.997% accurate. And I will be actually talking about what it actually means in the coming slide. And most of the pioneer organizations of Six Sigma users found that up to Sigma level of 6 is right trade-off between cost and quality. However, running a process in 5 Sigma, 7 Sigma is individual organization's personal call. That depends on the budget that they have and how much accurate that they want to get to, right? If an organization like Kishore says, where the aircraft, every part makes a major difference and it has to meet the standards, then I think it better operate beyond Six Sigma level, right? Now, just to talk a little bit about how Six Sigma got involved. In 1986, Motorola started noticing that their productivity was going down from 90% to, I think they came down to 10%, and the quality was pretty bad. And at that time, the CEO of that company, Bill Smith, he actually came up with this concept of Six Sigma. He coined the term Six Sigma and started rolling it out. What did he actually base the Six Sigma was on quality control, which was already there in the industry. And it's been there from 1920s, since Schuhart came up with his statistical process control. He talked about variation, he talked about standard deviation. So quality was not new then, but he actually compiled all of those concepts, total quality management and TPM, total preventive maintenance. He combined all those concepts and brought up Six Sigma, which actually was taken up by GE more seriously than Motorola. And they gave a statistical definition to Six Sigma, which we saw in the previous slide. And in the coming slides, I'll also show you what those numbers mean. Now, today, Six Sigma has been implemented across various domains, from aeronautics, from industries to manufacturing, to finances, and to even to the hospitals and medical healthcare industries. What are the key concepts of Six Sigma? This is very important for us to know before we actually get into some of the models that Six Sigma provides. So some of the common terminologies that are used in Six Sigma are critical to quality. They call it a CTQ. What is the CTQ? These are the attributes that are very important for the customer to be satisfied. These are defined by the customer, right? Going further, defect. It is very important to know what is defect. And here, if you can see, I've put it as failing to deliver what the customer wants. A defect is something that you have got it from your vendor or a manufacturer, and it's not meeting your requirement, then it is defective, right? It might be functional, but it is not meeting your requirements, right? The next is the process capability. What your process can deliver, right? How capable and how strong your process is, and consistently getting it every time, the repeatable and reproducibility of a process. And the variation, what the customer sees and feels. And at this point, I want to pause a little, and I want all of you to take a piece of paper. And I want our team here, because I can see the rest of the students online. I would want our core team, because I can see their thing, and probably we can share the video. If you can switch on your video and just do this activity for me. Pick up a sheet of paper, which, yeah, any now fold it into half. I want all the students to do this as well. Just fold it into half. Once again, fold it into another half. And I'm going to do it along with you, okay? Once you have folded twice, I want you to go to the top left corner and tear up a little bit of paper. Just tear up a little, okay? Once you have done that, just opposite to the same corner, just tear a little bit more. Just opposite to the same corner. Okay. And then open it up. So I got a outcome as this particular one, and I see Vijay sir looks much different. And he's actually tearing it up to match up with what I just said. So the point is that customer wants something, and we actually end up taking their requirements and end up giving them something else. So I wanted to tell you guys that variation do occur, but how much of a variation is acceptable, right? So now in current technology advancements and current days, variation is considered as defect. We do not allow variation because that is something that customer is not expecting. So this activity, I just wanted you to know that sometimes when customer asks something, manufacturer thinks something else, and they deliver something else. So that leads to variation, and variation is waste, or termed as defect, right? Moving on, stable operations are ensuring consistent, predictable processes to improve what the customer sees and feels. Further, it also talks about design for Six Sigma. Six Sigma has a major component into it, which is design for Six Sigma. And within design of Six Sigma, there is a model that we use, which I mentioned earlier, which is define, measure, analyze, design, and verify, where we are trying to actually rebuild a complete, from the scratch, a complete process or a product, right? We are trying to re-engineer the process completely. That is when we actually go in for design of Six Sigma. Now, I'm going to move on to the next. Sorry. Okay. What is a defect? We saw that variation is something that we don't like, correct? I also mentioned that variation is nothing but deviation from your mean. Now, statistically speaking, that deviation, if you square it, it becomes your variance. And if you actually put a square root to that variance, that becomes your standard deviation. And that is what your sigma, that symbol sigma, represents. Now here we are talking about defect. It's very important for us to know what is defect. Defect is defined as any process output that does not meet the customer's specification. I say something and you deliver me something else, which is not acceptable, right? And then we also talk about defect per million opportunities when it comes to Six Sigma. Now, what is this? There are two parameters that are there in this particular statement. One is opportunities. The other one is defects. Now, what are these opportunities? These are like you have to reduce the number of steps in either in producing the product or in processing a particular service, right? Reduce the number of handoffs, reduce the number of opportunities where somebody will go wrong, right? So those are the opportunities. And then there's defects, which is reducing the number of defects for each process step through continuous process improvement that will help improve quality. Okay. Defects per million opportunities. Continuing with the same discussion, on your left hand side, I have given you a chart which shows what a 1 sigma will produce. If a process is operating at a 1.0 sigma level, what does that mean? It means that it's only yielding 30%, 31%. If it is 2 sigma, it is yielding only 69%. The rest is a waste, right? Defect. 3 sigma is at 93%, which is much better than the 1 and 2 sigmas, but it's not there yet, right? And then the 4s and the 5s and the 6 sigma is yielding about 99.997%, which is just 3.4 defects per million opportunities. Now, this is why 6 sigma is considered a better process if your process is operating at 6 sigma, better than the 1 sigmas or the 2 sigmas or the 3 sigmas. And that's why we use 6 sigma. Okay. Phil Crosby, one of the quality gurus, he talks about quality is 0 defect. Now, in reality, is it achievable? That's a question. Some of the process, they inherently have some of the things that you cannot change, and it would yield some kind of defective products or processes. So in that case, what is better is to have 6 sigma. So you're leaving a little leeway to go wrong, but not too much, right? Okay. Now, this is a slide which is comparing 3 sigma versus 6 sigma. Now, if a process is operating at a 3 sigma level, which is 99% good, is it that good? Actually, it should be 93%. 20,000 lost articles of mail per hour. Not good, right? unsafe drinking water for almost 15 minutes per day. I would want to pick the one that happened yesterday. Too short or long landings at most major airports each day, right? Yesterday, we just had a major incident in Calicut, and it's very disheartening to lose our people. The plane got into two pieces, right? With the landing mistake, the rain and the skidding and all that. So 3 sigma is no good, is what I was trying to say. 6 sigma would yield one short or long landing every 5 years, which is acceptable, which is okay, but still not losing lives. And but from a process perspective, 3 versus 6 sigma is much better. Some of the quick facts about 6 sigma. Philosophy, it is a philosophy where it uses the steps as define, measure, analyze, improve, and control. Processes require inputs, which are termed as X, and produce outputs, which are Y. If you control the inputs, you will control the outputs. And this is the philosophy of 6 sigma, right? Have the right inputs so that you get the right outputs. And it is very predetermined. The goals are preset. When you enter into a 6 sigma project, you know exactly what you are trying to achieve. You're not going with exploring or inventing something new, but you are trying to discover where things went wrong, right? And this is generally expressed as the expression of y equals f of x. It is also a set of tools. Like I said, 6 sigma uses a lot of quality tools, QC, 7 QC tools, which were out there from many years. And they've been developed, and used by many companies. Control charts, failure mode effect analysis, one of the other powerful tool that 6 sigma uses to identify the risk, and it rates it based on the severance, occurrence, and detection. And there is an RPN number calculated, and that actually very, very helpful to prioritize the risk and address those based on the priority number. And then it also uses process mapping, right? Moving on, it is also a methodology. Like I said, it uses DMAIC, define, measure, analyze, improve, control, if you're trying to improve an existing process, or DMADV is used when you want to re-engineer or come up with a new process. And then there are metrics. That's, like I said, 3.4 defects per million opportunities. Now, these are the companies that have been using 6 sigma. In India, you can see there's a whole bunch of companies that have adopted 6 sigma. They have a full-fledged 6 sigma projects going on where there are dedicated 6 sigma black belts. And one of them, for member introduced me, I have a 6 sigma master black belt. And also have a Lean Six Sigma Black Belt project. So what it means is, if we guide a couple of green belts project, our black belts project, we get to a higher level. And these are some of the terminologies that we actually will see in the next coming slide. Here is a difference between DMAIC model and a DMADV model. The first 3 steps, it starts with defining a problem, measuring the problem. This measure phase will help us understand where the process is right now, as is. It is as is status. It will help us understand where exactly is the process right now, how it is performing. Then we do the analysis based on the measure phase using many tools like cause and effect diagram and FMEA. Use all of those and analyze and come up with improvements, on the here, the left-hand side, as I'm pointing, you improve the process, and then you control using some of the metrics, right? Control mechanism like auditing or review processes. But if you are trying to come up with a new process or a new product, and that requires a lot of re-engineering, then the first 3 steps are common, but then the 4th step is designing that new process, and then to validate whether you have achieved whatever was desired for. Okay, So this is the difference between DMAIC versus DMAD-V. And DMAD-V is part of design of Six Sigma. Okay. Some more differences. DMAIC is initiated from a problem. It's used in existing processes, organizations and customers, and process focused. Small team generally works on the DMAIC process. Short-term to medium time frame projects. Incremental improvement. So once you achieve certain milestone, then you set up a new milestone and you achieve that. So small incremental improvements. And then many projects available for improvement. So you identify quick fixes and then you start working on those projects. And it goes on. It's a Kaizen improvement. It's a continuous improvement. DMAD-V, on the other hand, looks for innovation solutions, innovation ideas, and is used for new processes or products. Then it's very much customer focused. A big team works for a long term, a big leap improvement. Unlike the DMAIC-V, which is incremental, this is like re-engineering the whole new set. You just scrap the old one and you just start off everything new from scratch. And then less projects available for improvement because it requires a lot of cost and takes time, right? So that's the basic difference between DMAIC versus DMAD-V. Just a little more in depth with DMAIC process, these are some of the basic questions that you would ask in each of these 5 phases. When it comes to DMAIC, the question you would ask is, who is the client and what do they value? This is very, very important for understanding where you have to start. What is that requirement that client has and which hasn't been met? Where is that gap? Right? Once you know what you're trying to do in your define phase, and there are various tools. In the next slide, I'll show you what tools are used. You get to the measure phase. And the question you would ask in this phase is, how do we know what value is and how do we measure performance? So you actually, if you answer this question, you will know where exactly you have to go for your data collection, and you start collecting the data, which will exactly show you where the gap is. Right? And then you move on to the analyze phase. And in the analysis phase, where it is based on your measure phase, you kind of put in a root cause analysis using Ishikawa diagram, which is also called as cause and effect diagram or fishbone diagram. And you see where the deviations are happening. What are those deviations that are causing variations in the process or in the product, right? And then you move on to the improve phase, where you ask the question, how can we eliminate or minimize these defects? So the goal is to minimize that variation. The closer the spread is to the mean, the better your processes are. The wider the spread, that means your products are moving away from your mean, which is not desirable, right? So the spread should be very narrow, closer to your mean. And the final phase is the control, where how can we sustain the improvements is the question. Yes, you have worked on these phases and you've brought in good improvements, but if you do not do the control part correctly, your process improvement project would fail because there's nobody to monitor the good stuff that you've brought in the company. The improvement aspect that you have brought in has to be constantly monitored. Otherwise, people tend to, probably deviate, right? So it's important to have the control phase. And these DMAIC is actually based on Schuhart's PDSA cycle, which is Plan, Do, Study, Act, right? Later, Deming called it as PDCA, which is Plan, Do, Check, Act. And this was actually introduced to Japanese by Deming, and Japanese took these concepts very, very good. And they actually manufacture products better than the Western world. Now, moving to this DMAIC project checklist. Here, I've given you a few of these quality tools that are used within each of the DMAIC phase. In the define phase, when you're starting off to understand what is the problem, you start with the initial set of data collection, and you identify who are the stakeholders. who would be impacted by your improvements, who are going to be impacted by the changes that you're going to bring. You're going to draft all that in your project charter. You identify the team. You get buy-ins from the management, which is a very key thing for Six Sigma to be successful. I have seen many Six Sigma projects failing because they don't get buy-in from the management. So it has to have a top-down and a bottom-up approach. It cannot be one directional, right? Moving to the second phase, where the measure phases, we actually start looking into the data collection part. And there are very many tools that are available, like Pareto chart, which is based on the 80-20 rule, the vital few from trivial many. You actually segregate top priority, which are actually contributing to your problem. You address those than the trivial many, right? You can actually ignore them because they may not bring in much improvement results. Then I have actually put in few lean tools here, which you see here, which is VSM, value stream mapping. It is one of the powerful tool used in lean methodology, where you identify your suppliers, the processors, and your customer, and you actually calculate the time taken for each phase, and you go into the depth to the point where you eliminate waste. You take out the non-value added steps. So that can be used in the measure phase of DMAIC process. Then there's gauge R&R, which is repeatability and reproducibility. You can use those. These are some of the powerful tools out there that quality has contributed to this field, and Six Sigma very much uses it in each of these phases. And moving on to the analysis phase, you have fishbone diagram, or it's also called as Ishikawa diagram. FMEA, as I mentioned, it is where you identify your risk, and you actually identify based on the severity, occurrence, and detection level. You give a rating to it. You get an RPN number, which is risk priority number, and based on that, you prioritize your risk and start addressing each of these risks with action items, specific action items, right? And then there is ANOVA analysis, regression, design of experiments. All of these tools provide a powerful mechanism for understanding why something went wrong and how can we fix it, right? And there's simple tools like 5 Whys, which are very powerful out there in the field of quality, which has been used. You keep asking why, one after the other. You continuously ask why, and you kind of get to the root cause of the problem. Moving on to the fourth phase is the improve phase. You try to do a mistake proofing. You come up with solution, which is poka-yoke, which this is a term that is used in lean methodology. And simple example for poka-yoke would be you're sitting in your car and you forgot to wear the belt. You drive a little distance and there is a beep going on, indicating that you haven't put on your belt, right? That is a simple example of poka-yoke. So you put in some improvements, such improvements where people don't actually go wrong. It'll tell them ahead of time, right? These are some of the tools. And then finally, you move on to the control phase, where, like I mentioned earlier, we kind of put in some review mechanism in place, audit mechanism in place, so that there is a monthly or a yearly auditing done to check whether these improvements are still on time, carried out, and still implemented, right? And if there is any corrective or preventive actions required, they correct it and they keep moving. Okay, so next would be the steps to implement Six Sigma. I just have given you some simple steps here. It starts with that burning desire to bring up some improvements, right? And that should not just be one individual in the organization. It has to be a collective understanding with a lot of buy-in from the management, because Six Sigma projects does involve some cost to it, right? And then put resources in place, teach the methodology. When I say teach the methodology, learn about the various tools that can be used within various phases, fit those tools that are applicable, and introduce those tools to the team members. Prioritize the activities, as in important steps. The important risk factors should be prioritized and addressed, and establish ownership. When you're assigning tasks, people should take the ownership to carry out those tasks, take the right measurements, govern the program, and finally recognize contributions, right? So Six Sigma also kind of emphasizes that once you have finished your project, you actually recognize the individuals who are part of it. And Motorola came up with these belts where they would hand out yellow belts and green belts to people who have contributed to such projects. Reasons for transition to Six Sigma, there are multiple reasons, and I've just listed here with their percentages. Six Sigma has given proven results, and we have seen that many companies have achieved that. And to be frank, I think Amazon also has extensively used Six Sigma, and today it's the best of the best. It's on the top Fortune 500 companies. Walmart has used it. So we have seen the results, how they have been performing and delivering things on time, right, for so many around the world. And then it allows for combined benefits with lean methodology. That is another good part about these methodologies, is that they complement each other. If there are certain tools that are used in lean manufacturing and you bring it along with the Six Sigma, the results are even better, and it results in process efficiency. And then waste reduction, customer service, cost reduction, and improved profits. These are some of the things that companies would be looking for, and they can be achieved through implementing Six Sigma projects, right? Okay. So these are some of the Lean Six Sigma belts that are available. If a company is totally Six Sigma oriented, this is how they would structure them. I am not very big fan of these white and yellow belts. What it means is that how much you contribute to the Six Sigma project. Now, for example, green belts contribute 25% of their time in the process improvement. Rest 75% is for their day-to-day activities, right? Black belts are dedicated individuals who actually coach the green belts, and all that they do is work on these process improvement projects based on Six Sigma. And then master black belts are more mentors to these black belts. They coach, and then they monitor and they lead projects. And then champions, they are the ones who are actually usually are the process owners. They own the organization, they fund the project, and they are very important key personnel to create that culture, Six Sigma culture. Now, is Six Sigma fading is the question. Now, if you ask me, what is my opinion? Definitely it is not fading. But there are instances where organizations are using Six Sigma, getting benefited out of it, but without realizing that they're actually implemented Six Sigma. What they do is they take all the benefits of these methodologies apply, these methodologies give out, they implement lean, they combine, and they come up with their own business excellence model. And many companies are doing it, and there's nothing wrong in it, but Six Sigma doesn't get credit for it. So some people might also start feeling that, oh, maybe Six Sigma is not implemented, right? So if you ask me, my opinion, it's still going on very strong. There are some failures because it didn't get implemented right. So based on that, some of the companies don't want to be very statistic oriented. Sometimes they also fear that it might get their job out, right? Because they are actually critically looking into some of the faults or defects in the process. And in the process, they're actually sometimes it's very easy to turn towards people than the process, it also sometimes it has reached saturation base where they have implemented Six Sigma, and now what further, right? They just stagnate there. And then victory has been declared too early, right? Sometimes they declare too early and they may not reach the end. Some of the companies started using lean more than Six Sigma because it's probably easier to understand, and they're quick fixes and less of a data gathering on the lean aspect. And and some companies feel that it's not the latest and the greatest thing, and there's no fancy in implementing Six Sigma. So many of them, they come up with their own methodologies, right? Moving on. It would be unfair if I do not talk about lean methodology when I'm talking about Six Sigma, because they go hand in hand. Lean methodology actually complements and supplies many tools that Six Sigma can just pick up in each of these phases and make the process better. Lean actually looks into these principles that I've shown here. It minimizes the waste. Lean looks into minimizing time and effort, eliminates rework, which is very important. Rework is also waste of time, right? So it's very important to reduce the rework, improve safety, increase productivity, reduce inventory, reduce cost, and pull scheduling. Lean believes in pulling versus the push system. The earlier systems were all push. You manufacture goods and you push it into the market even without knowing whether there's demand or not. Now, with the lean, when they know there is a demand, immediately they start pulling stuff to the market. So there's less inventory. And actually, one of the examples I can think about is Walmart. I lived in US for almost 14 years, and I've seen how Walmart works. In their store, they do not have inventory, a lot inventory, a whole lot. What they do is, when the products are getting lesser on the shelf, and there's two or three still remaining on the shelf, it triggers in the supply chain such a way that the vendor of that product ships it, and that product is coming on the truck. Most of their Walmart inventory is on the truck, on the road, and they amazingly have designed their supply chain, and that has benefited them a whole lot. Now here in the right hand side, this figure is showing how define, measure, analyze, improve, control kind of combines very well with the lean pull system. Here is a 7S, which is one of the key things in lean. It talks about sort, eliminate what is not needed, set in order, organize what remains, shine, clean work area, standardize, schedule cleaning and maintaining, sustain, make 7S a way of life, right? And then spirit is added to this, employee engagement across all levels. Finally, not to forget safety, create a safe work environment. So lean actually looks into all of these S, and they play a major role. Now, what is the difference between lean versus other traditional? Lean is more on a pull system versus the push. They're more proactive than the traditional one is more reactive. They're more preventive in nature, and the traditional one is more detective, right? And then lean is more simple, streamlined, simple. You can see the 7S, it's simple words, but it's very powerful. I use this at my home with my kids. Just simple, set everything in order. Put the things where you have picked up, right? So some simple discipline, which we can apply in our day-to-day activities, right? And then the teamwork, lean is more based on the teamwork, the team spirit, and the traditional is more on a individual basis. Now, lean thinking also looks into the value that it can create for the customer. It identifies and maps stream, which is the value stream mapping, a powerful tool again, and then creates flow by eliminating the waste, respond to the customer pull, and pursue perfection. So that's the lean thinking. On your right hand side, this is something I want all of you to pay attention to, because you guys are youngsters going to go out and look for jobs, and many companies actually have implemented lean, or maybe they have not. That is where your contribution might be very helpful. First, you might start understanding the ways that lean talks about. What are these ways? It used to be 7 ways, but recently they added one more, which became 8. So if you want to remember what are these 8 ways, just remember the word downtime, right? Downtime as an acronym for D, as in defect. Defect is something we do not want in our process or in our product. So that's a waste. O is overproduction. We don't want to overproduce and keep in inventory, right? So overproduction is not good. That is also a waste. Weighting of any resources. It could be human resources or the material or the machine. None of these should be made weighting. Weighting is adding to extra time. Time is money, right? Next, N is non-utilized talent. This is the 8th waste that has been added. And if you are not tapping into the skill sets that individual is holding, then you are underutilizing that individual. So that is actually a waste, and that's a very powerful waste. Many companies have overlooked for years, and now they realize that it's important that we actually utilize the talents that people possess in their company. T for transportation. Transportation is movement of the products from one place to other. If we can reduce as much as possible, that will help. Have the vendors closer to your manufacturing plant or to your service where it is needed. That way there's quicker turnaround, right? And then I is for inventory. Lesser inventory is better. M for motion. Motion is it's applicable to the operator or even the resources. No, don't move the resources around too much. That will add up to the extra time. And then E for extra processing, right? If you're drilling a machine, drilling a part, and you do extra rounds of drilling, that's not required. It's over processing. So those are the 8 ways. Now, combining Six Sigma and Lean, what are the benefits? If you look into the diagram here on the right hand side, Lean actually helps us to become more speedier, right? By removing the waste, increases the speed, removes non-value added process steps, fixes connections between process steps, and focuses on the customer. Now, what does the Six Sigma give? It actually focuses on removing the variation, improving quality, reducing variation at each remaining steps, optimizes remaining process steps, and focuses on the customer. So if we can combine Lean and Six Sigma, the benefit is more, right? Lean practitioners believe that waste comes from necessary steps in the production process that do not add value to the finished product, while Six Sigma proponents assert that waste results from variation within the process. So both are talking in the same language, and if you combine them, the benefits are better. Now, as I said, if I do not talk about and introduce you guys to design thinking today, then there will be a part missing, because most companies these days are talking in terms of innovation. There were days when in 1900s, when the industrialization started happening, mass production started happening, they were only looking at quantity of the product. Over years, they realized that if we just look at the quantity, it's not going to help. We have to look into the quality as well. Yes, quantity, more the quantity, better the cost, but quality has to be factored in. So companies realized this and they started looking into quality. 1980s is when they said, yes, quality plays a major role. Variation is something that we start looking into, not just the quality, right? The defects have to be reduced. And then now we are in an era where we talk about, yes, I want a product which is cheaper. I want a product which has good quality. Not just these two. I also want a product which is innovative, which is going to make me more comfortable using it, right? And that's when the design thinking comes into play. How is design thinking different from Six Sigma? Six Sigma has a set goal. The project has a set goal. When you enter Six Sigma, you know exactly what are you trying to achieve with it, right? But design thinking is more of an open-ended. When you're entering into this design thinking process, you're completely starting from scratch, talking to your customer first. You are empathizing them. I hope you all know the difference between empathizing and sympathizing, right? There's a major difference between these two words. Empathizing is you putting yourself in your customer's shoes and you're trying to understand what is it that they want. In order to do that, there are many tools that design thinking and these quality areas they provide. They use something called mind mapping. They have a central theme and they start putting the rest of the themes around it and they start connecting it, mapping it. So they learn from the audience. They start with the customer. Design thinking starts with the customer and it also ends with the customer, because whatever you have developed is getting tested by the customer and approved by the customer. So you start with empathize, you define what the problem is based on your empathizing phase. Then you move on to the ideate, where you brainstorm and come up with multiple solutions and pick one among them. Whatever is the best among that multiple solution, you pick one among them and then you prototype it. And then once you have prototyped your idea, it could be a process as well. I want to clearly state that this is not just for the product innovation. This also includes your process innovation. Now, once you do the prototype, you actually test in order to understand if it is meeting the customer requirement. These things are tested by the customers themselves. So it starts with the customer, ends with the customer. And these are not actually linear. There are times when they skip these and it becomes an iterative process and you can just come to any of these phases. This particular model was given by Stanford and it has been used by many companies now. Design thinking is appropriate if there's a deep understanding of the actual people involved. So I'm talking about the customers. If we are looking into applying design thinking, we need to exactly know who the users are, what are their requirements. We need to explore and get agreement with these users. There are many unknowns and past data is unlikely to help us. So we start from the scratch, unlike in Six Sigma, where it starts with the measure phase as is. You measure whatever the process is right now. You start from there. In design thinking, you actually go with the new set of data given by the customer themselves. And there's a very little relevant existing data to analyze. So you're exploring, you're going into a very open-ended area where you could go into any direction and it can lead to any kind of innovation, right? And on the right-hand side, you can see that these are some of the main questions that are asked when you're talking about design thinking. What is, that is becomes very important. What is that requirement for the customer? What is that the customer is asking for, right? That is becomes very important. Then you go on to say, what if I do it this way? Would it lead to that is? What if I do it in another way? Can I reach that is by the customer? And then we have what wows. So you have so many options out there that you have figured out which one is the best. Amongst the best, you pick which gives you and your customer a wow factor. Am I innovative now? Am I different from others? The wow factors, right? And then finally, you get to the what works. So you prototype and then you get to the testing phase. Has it worked? Has it met the is of the customer? Okay, the is that desire of the customer. Now here is a slide which is actually showing you a combination of design thinking and lean. And I have also put the agile. This has been used by Gartners, and they start with these design thinking, which is an open-ended methodology, and they get to the lean methodology, which is more of a closed end, and you know what to. Then agile, which goes on as an iterative process in a day in day out methodology, and these are quick fixes. Using agile, you can bring in the quick improvements and kind of fit into your process improvement project. So the design thinking phase, where you see that customer problems are defined using these empathize, define, and ideate. Initially, you start off with a concrete, then you kind of get into the abstract because you get to an unknown area and you're trying to figure out which one is the better solution. And then you kind of move to the lean concepts where you measure and build and learn from the, and then it goes on. It's an iterative, experimentative process if you're combining these methodologies, and they work very well together. Here is my contact details. Guys, if you have any questions, I do not know if there is time and if sir allow us to take
Maybe
questions.
there are about a dozen questions. It's there in the Q&A box at the bottom.
Let me click on that. Do I have to stop sharing to get this?
Maybe.
Yeah, okay, it's working. Let's see. Okay, so we're going to start from, there's a bunch of questions here. Okay, hello ma'am, I'm from ASRVC2. You just said Six Sigma is used in various domains. We use Six Sigma in our studying education process to improve our grades. If we could, how to implement it? A very good question. Can we use Six Sigma in our own studying process? Definitely. It probably might get you more organized, where you're defining exactly where you have to focus on with the syllabus, and then you kind of measure where exactly, how much have you studied, how much do you know, and you can analyze yourself, what are the distractions that might cause you not to study, and then you kind of come up with an improved, the better steps, and then control it, right? So yes, definitely you can apply. And actually many education sectors, academics have used Six Sigma to improve their process. Where was I? One second, just bear with me. I'm just trying to get to, I don't want to miss any questions here. Are design thinking and Six Sigma mutually exclusive? And that's what I was trying to tell you. Design thinking is an open-ended approach where you do not know exactly how the innovation is going to turn out. There is an overlap between design thinking and Six Sigma demand V process. Demand V process is kind of where you design and verify, right? You are re-engineering a process, and there might be few things that are overlapping with design thinking and Six Sigma. But Six Sigma projects usually gets in with a closed goals. You already have determined the goals and you're trying to achieve those goals, okay? Six Sigma is equal to 99.999966% good. How may and which sigma is required to achieve the rest, 0.0034% good. Now, here is where a challenge would come in for the companies. Six Sigma do cost, right? If you're trying to bring the entire organization to a Six Sigma level, that means you're investing in black belts, you're investing in huge projects, you're bringing some of these green belts out of their regular task to process improvement. So it would cost. So there is a balance that has to be maintained between getting into these process improvement and actually doing it. So what they do is they actually get this culture with the lean and Six Sigma. They bring in those tidiness, they bring in those waste concepts in their day-to-day activities, and they try to maintain. So I think that if a company is operating at Six Sigma, it's pretty good. If they try to go beyond that, yes, it will incur some cost, but there is no stopping. It's up to the companies to decide, and they can get to better than Six Sigma. Who knows? We might end up in a state where it's zero defects, right? Can AI, artificial intelligence, used in DMIC process to set, sorry, where is that? I lost the question, one second. But, can AI be used in DMIC processes to set the Six Sigma? Artificial intelligence can definitely play a major role in some of these improvements that we are going to bring in. For example, we have a problem we have defined a problem in the defined phase, we measure it, and when it comes to cause and effect analysis phase, we do the cause and effect, and we find that the company can probably automate some of their processes. They don't have to spend too much time in manually doing stuff, right? That's where probably the artificial intelligence can come in. We can put in some of these IoT based concepts. Yesterday you guys have gone through a very nice session by one of the personal who did talk about IoT, right? So you can implement these kind of concepts, bring in artificial intelligence in the improvement step, and get to the control phase. But it does involve a good understanding of how the Six Sigma project has to go, what are the costs that are going to be incurred by implementing AI, because some of these could be huge. We're talking about replacing machines that are based on AIs. We're talking about replacing people who are not yet up to the AI level. So these can cost to the company. Will the Six Sigma process result be affected due to human errors? If yes, is the 99.997% accuracy inclusive of that? Yes and no. Sometimes yes. For example, yesterday's, do we consider it as a human error, or do we consider it as a natural calamity where no, the roads were wet and skidding were happening? We don't know. Certain things happen. There is always the factor of human error there. But what Six Sigma does is it does look into training the individuals who are working on the processes so that they're skilled enough to get the best results in their process. Most of the quality and improvement methods or techniques adopted are from Japan. Are there any Indian techniques or methods adopted to improve quality management in manufacturing? See, what I would say is some of these concepts are out there from years. Whether it was developed in Western world or whether it is being developed in Japanese or India, it all depends on how matured the organization is. Our organizations in India, where we are more into agriculture, we were more into agriculture rather than manufacturing, it is hard to say that did we actually come up with these concepts. We were using many of these concepts. We are very good in statistics, but it depends on how open the company is to get these numbers and act upon it. And it's an act. It's an act that management has to develop and kind of float it across. How SAP in companies helpful for Six Sigma? Now, SAP is a product that actually kind of gets everything centralized, right? And Six Sigma talks about defect reduction, variation. Now, everything is centralized. There is nothing that can go wrong because it is intertwined with each other. You are reducing your variation and they go hand in hand. And many companies which have adopted Six Sigma methodology, they end up recommending let's shift to SAP, right? Is creativity required for design thinking? Definitely yes. And that is why the steps that I showed doesn't sometimes go in an iterative way. They actually get to the final step. They sometimes prototype early and then they come back and they think through and then they go. They do not want to stop their creativity. And actually empathizing phase starts with mind mapping, where people are thrown out in the field. They go out, they start looking, observing stuff. They come back individually. They start putting everything on a chart with a nice cloud around, and they start interlinking, and all of the thoughts are brought together. So creativity plays a major role in design thinking. What is difference between Six Sigma and world-class manufacturing? See, world-class manufacturing might talk about implementing industrial IoTs. It can talk about bringing up new products and services, right? How do companies achieve such things? It could be through using Six Sigma. It's a very structured process to get to your bettering of the process or a better product. Not sure if I've answered all. Okay, why is there no feedback loop? Why is there no feedback loop in DMAD-V or DMAIC process? Very good question and a very good observation. This is more of a, you complete a phase, you complete the defined phase and you go to the next phase and you actually don't go back. And sometimes they do go back, but there has been cases where the projects have failed due to this strict structure. But in my understanding and my advice to you guys, if you are implementing DMAIC and DMAD-V, definitely loop it back to each of these steps, and they are intertwined. You cannot treat each of these phases separately. Is there any new technology in alternative of Six Sigma? Six Sigma is not a technology, it is a methodology. Okay, there is a difference between the technology and methodology. Now, new technologies can be used in Six Sigma. And what are those new technology? I'll just give you an example. Back in those days when I was implementing Six Sigma with one of the IT companies, when we had to collect the data, we were using a lot of Microsoft Access, we were using a lot of Excel, and then we would categorize these data based on the attributes that has to be concentrated on. But now, because of the technology advancements, there's something called as robotic process automation, RPA, where these smaller bots are created. These are nothing but the set of programs which are run in the back end, and they will give you the results, right? And you don't have to look in different places and create a consolidated view. They actually do it for you. So yes, new technology will support Six Sigma and it will better it, and vice versa. Six Sigma, if you have to implement new technology in your company, Six Sigma can be a methodology that you can use. Okay, according to you, does the Six Sigma concept fulfill the Six Sigma specifications, like having 99.9997% success rate? Now, very good question. Sometimes the calculation and the understanding might go a little different. For example, I had a challenge when I had to implement Six Sigma in a development organization. These were hardcore programmers who were getting the set of codes, each day, and defining defect for them, where each line of code should not have any defect in it, anything that is acting against the customer requirement, right? In the testing phases, when they use this use cases, they should not find any fault. So it was a challenge for us to exactly define what is a defect at that level. And we did get to the Six Sigma level, but there is still a speculation that whether we actually assumed some of these correctly or not. It is a lot easier when we do it on a product versus a service or a code, line of code, According to you, does the Six Sigma, okay, I think I answered that, right? Well, according to you, does the Six Sigma concept fulfill the Six Sigma specifications, like having, okay, that I answered. Let me move on to the next. As we know about the 6 degree of freedom in the industry, which is used to do some complicated design, but there is a concept about 12 degree of freedom, design of experiments, okay? What will make this concept good while under the boundary of Six Sigma? See, Six Sigma is a methodology again where you have these 5 phases for improving a process, right? Define, measure, analyze, improve, and control. In the analysis phase, it is up to you to define what are those factors that you're going to consider and work on and do a multivariate analysis or ANOVA testing, come up with a hypothesis. All of these are up to you, and it depends on what is that improvement that you are looking for. Any questions that I have missed? Guys, I think we also have run out of time. So what I would say is you guys are great and having great questions. I have my email put up in the last slide, and also I can share with you all I think I've shared with Reddy sir and also Dilip Babu sir about my contact number and details. You can probably reach out to them, or you can actually email me here on archana@rec.edu.in, and I'll be happy to address all your queries. With this, I also want to thank Dilip Babu sir and Reddy sir for giving me an opportunity to talk about these quality methodologies, Six Sigma, Lean, and design thinking to all. And probably I've got you a little thinking going now, because I see the questions are great. Please do email me if you have any further questions.
So, thank you very much, madam, for your wonderful talk. I'm sure the quality is very important for the future of manufacturing in India and in the service sector also, I suppose. So thank you very much for highlighting that.